Okay, think about this. You're using it right this second. In fact, you're probably using it almost every second of every day. But have you ever really stopped and wondered how the internet actually physically works? I mean, what is it? Let's get into it. You click on a video, right? Maybe a cat video from a server halfway across the planet, and somehow it just appears on your screen instantly. I mean, it feels like actual magic, doesn't it? Well, today we're going to pull back the curtain on that magic trick.
Because here's the first thing you absolutely have to understand. The internet is not some invisible cloud just floating up in the sky. Nope, it's something way more incredible and way more real.
So let's start with the internet's actual physical backbone. And trust me, it is so much bigger than you can possibly imagine. That's right. The thing that connects our entire world that feels so wireless isn't wireless at all. The global internet is a massive tangled network of actual physical cables running under the ground and, get this, lying on the bottom of the ocean.
And when I say massive, I am not kidding. We are talking about more than 1.2 million kilometers of cable. That is enough to wrap around the entire planet almost 30 times. This is the real information superhighway.
Now this right here, this is a huge myth buster. So many of us think, oh, it must be satellites beaming everything around. But nope. Satellites handle less than 1% of all global data. The real workhorses, the things doing over 99% of the heavy lifting, are these undersea cables. So what are these things? Well, they're not your grandpa's copper wires. They're called fiber optic cables, and they're made of these incredibly thin, pure strands of glass. And here's the wild part. They don't send data using electricity. They use pulses of light. Your data is literally traveling at the speed of light through glass tunnels at the bottom of the sea. It's insane.
All right, so we've got the highway. Now what about the cars driving on it? Let's follow one tiny piece of your data on its epic journey across the globe. Let's meet the hero of our story, the data packet. See, your data doesn't travel as one big thing. Any file you ask for, a picture, that cat video, whatever, it gets sliced up into thousands, sometimes millions of tiny little pieces. We call them data packets. Just think of them like individual pieces of a giant jigsaw puzzle. And here's how that whole system works. First, your file gets chopped up. Then, every single little piece gets a label with an address on it. Then they all get shot out onto the highway, and on the other end, they get put back together. It's an unbelievably efficient way to move huge amounts of information without causing a global traffic jam.
But wait, how do these little packets know where they're going? Well, every single device connected to the internet, your phone, your laptop, a giant web server, has a totally unique address. It's called an IP address. You can literally think of it as a street address for the digital world. Okay, but the packets don't just take one road. Their journey is guided by millions of these little specialized computers called routers. You probably have one in your house. They're kind of the unsung heroes of the internet, making millions of decisions every single second. And this is the perfect way to think about it. A router is like a traffic cop at a massive intersection. It looks at a packet's destination address, checks all the possible routes it could take, finds the fastest, least busy path at that exact millisecond, and points the packet in the right direction. And what's really crazy is that different packets from the same file might take completely different paths across the world to get there faster. So all these little puzzle pieces are racing across the globe toward one final destination, but where are they actually going? They're all heading to one specific computer, which is called a server. And that server lives inside a massive, super secure, climate-controlled warehouse that we call a data center. So when you go to a website, your request is literally traveling to one of these buildings. A server is really just a super powerful computer that never, ever sleeps. Its whole job is to store files, websites, videos, all that stuff, and, well, serve them to you whenever your data packets show up asking for them. So the server does this 4-step dance. First, it catches all your incoming packets, which, remember, could arrive all jumbled and out of order. Then, it uses their labels to put the puzzle back together and figure out your original request. It finds that cat video you wanted, and finally, it breaks that video file into a whole new set of packets to send right back to your IP address. The request is fulfilled. And now, the journey back begins. And this whole thing happens in literally the blink of an eye. These new packets, the ones holding the video you actually want to see, now blast back out onto that global highway. They zip through the same routers and the same undersea fiber optic cables, guided every step of the way right back to you. And here it is. This is the part that just blows my mind. The time it takes for your request to go from, say, New York to a server in London, find the data, and for that data to come all the way back, it's about 200 milliseconds. That is less than a quarter of a second. It's a staggering feat of global coordination. Finally, all those new packets arrive at your device. Your computer or your phone catches them all, quickly puts the puzzle pieces back together in the right order, and bam, the cat video starts playing on your screen. So the next time you're scrolling or streaming, just remember this. The internet isn't some fluffy, abstract cloud. It is a sprawling, physical masterpiece. It's an incredible network of glass carrying pure light, directed by unbelievably complex mathematics, all working together perfectly to connect our world. Pretty wild, right? So, what part of this journey surprised you the most? Was it the sheer scale of all those undersea cables, or just the mind-bending speed of it all? Let us know down in the comments. And while you're there, tell us what other piece of invisible technology we should break down in our next explainer.